All right, does everyone have their chart?
Yeah.
All right. Quiet down. Here's what I need you to do. You're filling in the chart as we go around. So make sure you have a pen or pencil. As you listen, you're filling in your chart.
Oh no, I'm gonna be leaving in like 5 minutes.
All right. Who had specialization?
That was us.
Okay. So what is it? What does specialization mean?
It's an increase in efficiency by narrowing the range of tasks and roles involved in production.
Okay, so narrowing tasks and roles in production. So for example, instead of producing 5 different crops, you're only producing 1. Instead of producing corn and soybeans and lettuce, you're producing just corn. All right, why did the trend occur?
Because there was an increased food demand.
All right, so there was an increased demand for food, and so farmers said, well, how can we make sure that we provide enough food for all of these people? And they said, well, if we specialize and we only grow 1 crop at a time, we can get really good at growing that 1 crop and we can produce more food. How has your trend impacted agriculture or other parts of the food system?
Assembly line.
Okay, so we have a lot more of assembly lines in food production. So lots of this is going on in factories, in different areas of food production. Basically, everything is super specialized, right? Like a company will produce milk products or yogurt, okay, or just one type of thing. All right, mechanization, is that you guys up front? All right, what is it?
It stops pushing something done by humans to be done by machines.
Okay, so use of machines instead of humans. So we talked about the Industrial Revolution, where industry got a big boom because they were using all these new technologies and machines. Same thing happened in agriculture. Why did it happen?
There was advancements in technology that made the workforce go to 2% in agriculture.
All right, so advancements in technology. And as a result, they needed fewer humans because they had machines now to do their jobs. Okay? But advances in technology allowed them to create the machines that then replaced the humans. How has it impacted agriculture or other parts of the food system?
Other jobs are able to be done more efficiently with machines.
Yep. So we can say replaced humans for work because they were able to do it with machines now. All right, next up, rise in chemical and pharmaceutical use. Who had that one?
Us.
All right. Chemical use, what is it?
Increase in the use of synthetic fertilizers, chemical pesticides, and antibiotics.
All right, synthetic. I'm just going to write pesticides and antibiotics. What does the word synthetic mean? Fake or man-made? Man-made. All right, so an increase in synthetic pesticides and antibiotics. Okay, why did it happen?
It increased crop production with fertilizers and pesticides and spend less money on antibiotics. So animals gain weight faster on less.
All right, increase in production, both on animals and crops, okay? If we have pesticides, pesticides are chemicals that are used to kill pests. Okay, so insects. If you have insects eating your crops, you're not making as much money on those crops. Okay, same thing. Diseases. Okay, if I shove 100 people all in this room and one of them's sick, what's going to happen? You're all going to get sick. So you remember all those chickens that were shoved together in a room? If we shove a lot of chickens or animals all together in a room, typically what happens is they get sick really easily. So we use antibiotics, and then they don't get sick as easily, but it comes with a cost, okay? So we can decrease the amount of organisms that die from being sick by using antibiotics. Okay, and then how has it impacted other parts of the food system? Okay, so gains in productivity, so increased productivity. The other thing I want to point out is that it also has led to resistance. Some organisms are now becoming resistant to antibiotics or resistant to herbicides. So now we have these weeds that when you spray them, they don't die because they've evolved to be resistant. So all of this chemical use has caused resistance. All right, consolidation, who's got that one? All right, what is it? Okay, fewer and larger farms. So instead of lots and lots of small farms, we have a couple that are really, really big. So fewer and larger farms, why did this happen?
Just it's Becca's birthday. And then it's Becca's birthday.
Why did it happen?
Okay, happy birthday, Becca. Are getting larger and smaller farms are really not.
Why did they get, oh my gosh. Sorry to anyone who's listening to this birthday song.
Happy birthday, dear Becca. Happy birthday to you.
I'm sure she loved that.
I love it.
Okay, why did we get fewer farms becoming larger? Because what? Okay, so it basically, they were able to be more productive, okay, and decrease costs by having these larger farms. So decreased costs. So if you have one big farm, these big corporations basically can control a lot of stuff, and the smaller farms go out of business. How has this impacted the food system? Okay, so food production is now on a massive scale, meaning no longer are we just having farms where they're producing small amounts of crops and small amounts of food, but we have farms that are producing thousands and thousands of pounds of food. On their article, okay, it says market concentration, which is what we're going to read next, which goes along with these fewer and larger farms. So on market concentration, it has a picture of a cow, okay? Cattle, okay? 82% of our cattle is raised by 4 companies or produced by 4 companies: Cargill, JBS, Tyson, and National Beef. All 4 of those companies produce 82% of all of the beef you see in grocery stores, okay? So, market concentration, what is it? Okay, small number of companies own a large share of the market, okay? And when we say market, we mean like the chicken market or of beef or of oranges or whatever, okay? So why did it happen? Okay, so it happened because companies outcompeted small farms and owned more of the share of the market then. And lastly, how did it impact food industry?
So lower the prices of agricultural products because one company has control over them.
So it lowered prices. Okay, so it lowered prices as a result. All right, I would like you to keep this sheet with your notes. Okay, you can head back to your seats. If you have any of these articles that you need to turn back up to me, otherwise that chart goes with your notes. And then you need to get your notes out. The graph stays with your notes.
Never mind.
You do not need to turn it in. You're keeping it. All right, I'm missing some sheets. Where are they? Anyone have them? No? All right, so get out your notebook. What I want to review are some of the terms from yesterday first. So we talked about NEPA. What's NEPA? National Environmental Policy Act. It required what? EIS, Environmental Impact Statement, to discuss how the plan was going to impact the environment and the surrounding area. Okay. We also talked about urban sprawl. What's that? Cities spread out. Okay. What's the problem with urban sprawl?
Pollution.
Pollution and more traffic. Okay. We also talked about urban blight. What is that? The cycle where what?
Where people leave.
People move away from the cities and the city deteriorates. Okay? What's an ex-urban area? Outside the suburbs. When we talk about undernourished, what do we mean?
People who aren't getting their right.
They're not getting enough calories. Not enough calories. Okay? So they're underfed. What about overnourished? Too many calories. What about malnourished? Not enough of the right calories, so they're lacking nutrients. Okay, what's a food desert? Yeah, so it's an area typically that has low-income individuals and they don't have access to healthy or fresh food. What's an energy subsidy? Amount of energy used to produce a calorie of some type of food. So what requires high energy subsidies? Beef and fish, okay? And then plants have a low energy subsidy. Where is food security high? United States, developed countries. Where is it low? Developing countries, Africa, Southeast Asia. Good. All right, put your phones away. On your note packet, we're going to do some notes and we have an activity. So, advances in agriculture allowed the human population to increase exponentially. We saw this. You guys did the timeline yesterday. So 10,000 years ago is when agriculture began. So you need to fill this in on your blank. Humans began practicing agriculture 10,000 years ago. Okay? Plowing and irrigation started, 3,000, 2,000, 3,000 years ago. And then the Industrial Revolution, where we get all of those factories and technological advancements, happens in the 1900s. Okay? So just like how we said we have the Industrial Revolution, we had all this new technology, at roughly around the same time, kind of after that, a little bit after that, we have the Green Revolution. And this is a revolution in agriculture. It's not in technology and production and industry. This is a green revolution. So it's an increase in crop production in the 1900s. So it's after the Industrial Revolution, due to all those things we just talked about. Technology, machines, fertilizers, irrigation, which is watering, and then creating new crop varieties. And so they were able to increase crop yield or crop production, meaning how many crops they were getting. Anyone need a packet? Sorry, I didn't ask. No packet? Okay. So if we look at this graph, the green is areas harvested. So the area that's being harvested is the same throughout the years, okay? So they're planting the same amount of crops in that area, okay? But the difference is the yield and the production, how much we're getting out of that land, is increasing. And it's increasing because of stuff like mechanization. Now we have machines that can plant the seeds in the ground. Fertilization, now we know how to make fertilizers. Irrigation, we have watering systems that can help. We have new crops that make more food. And so they have brought some of these techniques to developing countries in order to increase that food security that we've talked about, so that they can produce more food on the land that they have. So the Green Revolution then led to this idea of industrial agriculture, which is that article that you just divided up in groups and read. So industrial agriculture is agriculture that focuses on maximizing food output, maximizing the amount of food that you produce, while minimizing cost. So having as little cost as possible. So they don't really care if there's a ton of chickens stuffed together in an area. Okay, what they care about is profit. How can we make the most money off of these chickens, off of these animals? It's okay if they get sick or if they're not in the best living conditions. How can we make the most money? Good? Okay. So characteristics of industrial agriculture. First of all, economies of scale. What does this mean? It means that instead of small scale, we're doing it on a very, very large scale. So it's more profitable to have large farms rather than many small ones. And like we saw, 81% are controlled by 4 companies for cattle. Similar stuff for the rest of it. Most of the food that we eat, we don't even know where it comes from. It comes from these big, big farms, okay? The carrots you get probably are not coming from Wisconsin, right? Bolt House carrots, they have a huge farm in California, and that's where they make all those carrots, and then they ship them out to all different parts of the United States. So the problem with that then is that we have to ship them a long ways, right? And so we're using fossil fuels. If you think about it, you guys can get whatever food you want whenever you want at the grocery store, okay? You can get a watermelon in December. There's probably watermelon there. You can get oranges in December. You can get strawberries. Do strawberries grow anywhere around here in December? No. Or in February? Nope. But guess what? We have fossil fuels, so we can truck them in, okay? 150, 200 years ago, people did not have fruits in the winter because they didn't grow here. Okay, and they didn't have the means to bring them to other places. So large farms with over $1 million in sales account for 4% of all farms. So if we count up all the farms, 4% of them, okay, are these large farms with over $1 million in sales. Okay, only 4% of all the farms are large farms, but those 4% of farms account for 66% of sales, 66% of the food that we eat. So even though there's only a couple farms, they're so massive that they provide all of the food, or a lot of the food that we need. So some of you have done the food mile calculation with me. So I've made some of my students calculate how many miles did your food travel. Okay, if you're thinking about what you ate for lunch, if you had pizza, where did the cheese come from? Well, chances are your cheese probably came from Wisconsin, which is great because we produce a lot of cheese here. Where did the pizza sauce come from? Where did the tomatoes in that pizza sauce or the garlic? Where did the crust, the flour from that crust come from? Okay, if you add up all those miles, that's how many miles your entire meal traveled. So food mile, the distance traveled from where the food was produced to where the food is eaten. And the average food in the U.S. travels 1,500 miles. 1,500 miles to get to your table. All right, so monoculture. Mono means what? One. So using land for only one type of crop. Anytime you see a cornfield, you are looking at monoculture. So the disadvantage, it promotes disease, which we'll look at in a second, and it depletes soil nutrients, because if you're always harvesting the same crop and planting the same crop, over time, it's going to use the same nutrients over and over and over again. And as it uses those same nutrients over and over and over again, the soil is going to lose those nutrients. All right, we'll do that in a second. We have this one and one more slide, and then we'll be done with notes. So mechanization, use of machinery. Okay. So machinery can be tractors and plows, but it doesn't have to be. It can be stuff like these milking machines. So what are the disadvantages? It compacts soil because our machines are pushing down on the soil, right? And we know that if soil is compacted, the roots can't grow very well. It can't drain very well. We have to use fossil fuels. It also increases erosion. Imagine if you're tilling. If you're tilling, you're probably breaking up all the roots that are holding that soil in place. And as a result, that soil is more likely to blow away. And last but not least, for today at least, irrigation. What the heck is irrigation? It's watering systems. So before, we had to figure out how to water things. Okay. This is a problem because we can deplete our underground aquifers, our water supply. It also degrades soil. So if something's waterlogged, it's full of water. So just like this, if soil's waterlogged, it means it remains underwater for a long period of time. So just like yesterday when it was raining like crazy, our soil was underwater. Now if a place gets flooded for a while, that's pretty bad for plants. Plants can't grow in that. They can actually drown. Their roots do not do well when it's completely saturated with soil. And these two are two big terms that show up on AP exams a lot, waterlogging and salinization. Salinization, salinity, refers to salt, okay? So now I'm not talking like, oh, they water the ground with salty water, like, but what happens is there's salts, and not just like table salt, but stuff like magnesium and calcium, things that we consider salts from a chemistry standpoint. They're in our water, and what happens is when they evaporate, they become really concentrated. So just like if you were to put a cup of water, of salt water, on your windowsill, the water would evaporate, it would leave the salt behind. Okay? So what happens when we water all of these lands over and over, and some of that water evaporates, the salts are left behind, and the salts get really concentrated. This is not snow or water on this field. This is actually white salt that has become very, very concentrated. Okay? And salt is pretty deadly to plants. They can't grow in really salty conditions.